Aaron Dominion, and welcome to the Creation Kit scripting series Papyrus tutorials. This is the 10th part of the events and functions segment, and in this episode we're going to talk about, continue with recursive functions and talk about specifically return value parameters. So what is a return value parameter? It is a parameter, or argument, however you call those variables that you add into your function call. It's basically something that will be returned whenever you reach the base case at the very end. Why would you use something like that? Because of it being nested in the function call itself, you reduce the amount of calculations when the function call stack goes back up. So let's say Factorial. If you keep track of the result of Factorial every time you go down the chain, at the very end you just return the final result because it's already all calculated. And it cleans up your return statement slightly because of that, because you have it in the argument section as opposed to just doing the calculations on the fly in the return. So let's dive into examples. I'm going to preface this by saying we're reusing examples because I couldn't think of anything offhand that fit these conditions. There definitely are things out there that fit return value parameter recursion, but these are the easiest things to go over since we've already looked at them. Factorial. Bad Dominion. We are tired of this. Yes, I'm sorry. So you turn Factorial into a two-parameter system, kind of like how we did the going from 0 to whatever desired value, except the second parameter is only to keep track of your result. And base case, you just return 1 times your result. Otherwise, you're going to reduce your number, and then you're going to do the number times the result. This current implementation that we have on the screen, and we'll see in the script file itself, has one bug for the result, but we'll get into that in the live coding. Fibonacci is the function that's probably going to see the most change. Fibonacci can be calculated more efficiently to where you don't have branching statements and repetitive calculations. So what we want to do is keep track of our desired value, the current value we're at, one previous result, and another previous result, because Fibonacci, for values that are 2 or greater, is the first result plus the second result. So the first case, if both your current value and desired value is 0, you just return 0. Similarly, if it's 1 in both cases, you return 1. And now we're going to go back to 0 real quick. If current value is 0 and desired value is greater than 1, then you return the next call with 0 as the first previous result. Likewise, for case 4, if it's 1 and the desired value is greater than 1, then you return the next call with 1 as the second previous result. If current value is greater than 1 and it's even, you add the current value that is even. You're going to return the next function call with your first previous result being your current previous result, number 1, and the second previous result that's currently recorded. So let's say for 2, it's going to be 0 plus 1 because 0 is in your first previous result spot and 1's in the second. And it's going to rewrite the first previous result to be 1. So the next case, if current value is greater than 1 and it's odd, you're going to return the next call with previous result 1 and previous result 2 added together again, but instead of assigning it to the first previous result, you're going to assign it to the second. And each recursive call is going to just flip-flop over and over and over and over until we reach the base case if the current value is equal to the desired value and it's greater than 1. What we're going to do in that case, you're going to just add the previous result number 1 to the previous result number 2. Because of the even and odd, I think we need to go into this next segment. I also see a problem with this right now, as it is. We're not detecting just if the desired value is 0 or if the desired value is 1. That might actually be better than just seeing what the current value is. So detecting even and odd. Remember, if you watched the variables about integers, the operation modulus, well, we'll need modulus for this. So any number mod 2, if there's no remainder, that means it's even. If there is a remainder, that means it's odd. So, for example, 2 mod 2 is going to be 0. That's an even number, as we know. 3 mod 2 is not 0, so it's odd. Let's go and play around with stuff now. For the purposes of this, I'm going to drag this off to the side and leave that open. Let's go and look at our creation kit cell at the function as it currently is. See, there's no parameters, some debug boxes that I've put together, and we have our current factorial, although I made the change here already for the result. Let's look at it in our Notepad++ window, though. Whenever you give a parameter a default value, a value like this, its default value. I didn't cover that in the earlier function segments. I'm going to go back to that after recursion just to touch up on it. And let's start off with coding up Fibonacci now. Also getting comments out for those. So input desired value, current value, first previous result, second previous result. And the purpose of this function is to calculate a Fibonacci. Okay, sorry, I had to stop in the middle of the coding a moment ago, so let's see where we left off. So the purpose of this function is to calculate a Fibonacci number more efficiently. Okay. So let's do int function, so Fibonacci return param, and we want to have int desired value, int current value, and we're going to have that default to 0, int first previous result, and we're going to default that to 1, and int second previous result, and we're going to default that to 0, just so we don't have any weird cases. Base case 1, if desired value is 0, if desired value is less than 1, no, we'll just say 0, we want to return 0. Second case, 2, if desired value is 1, else if desired value is equal to 1, we're going to return 1. And this is the next case. So case 3, if desired value is greater than 1 and current value is 0, else if desired value is greater than 1, let's do this just so we can encapsulate each of them, and current value is less than, we'll just say 0, even though it's better to do it the other way. Return, and then we're going to call our function again, return param on desired value, comma, and then we're going to do current value plus 1, and then we're going to place 0 there, and then we're going to just pass on second previous result. Case 4, if desired value is greater than 1 and current value is 1, so desired value is greater than 1, and we're going to have the current value is equal to 1. We're going to go and return Fibonacci, return param of desired value. We're going to increase the current value again, and we're going to have first previous result passed here, and then 1 passed in the second previous result. So case 5, this is where we're going to start doing the iteration. If current value is greater than 1 and current value is less than desired value. Else if, and current value is even. That's important here if determining, so current value is greater than 1 and our current value is less than the desired value, and even func of current value. We'll define that in a moment, the even function. So return Fibonacci, return param, and we're going to do desired value again. We're going to increase the current value, and we're going to go here, and this is where the change happens. Previous result, and then we're going to add the second previous result. I notice that's going to be our new first previous result, and this is going to be the second previous result still. So case 6, if current value is greater than 1 and current value is less than desired value and current value is odd, we're going to do another else if current value is greater than 1, current value is less than desired value, and we're going to do it like this just so it knows what to take the opposite of, because The way we can do not even function of current value is because the way we're going to implement the even function, it'll return true if it's even and false if it's not even, and taking the not of false makes it true, so whenever it's odd it will be true. Okay, so return of Fibonacci, return param of desired value again. We're going to up the current value by 1 like we have been. We just want the first previous result in the first previous result spot. However, here's where the change happens. In the second previous result, we want the first previous result added to the current second previous result. And then base case 5 or 3 if desired value equals current value and greater than 1, let's say. So else if desired value is equal to current value, and it doesn't matter which one we do here since they'll be equal. Let's say that one. And then we just want to return the first previous result. Let's encapsulate this in parentheses though. First previous result plus the second previous result. And then we're going to have just a error case because of how this is implemented. Else return -1. End if. Okay. So that's our Fibonacci function. Let's get to the even function now. So, alright, so inputs are number to test, and the purpose of this function is to determine if the number is even or odd. Even is true, odd is false. Okay. So we want to make this a bool function, and even func is what we called it, and then int num to test and function. Okay, so we're going to do the even test. So if num to test mod 2 and we're going to test to see if that's equal to 0, return true. So if not even must be odd. This method that we're doing will not work for negative values, but for the purposes of this episode it doesn't matter. So just going to do a simple else and return false. Okay. So everything should be good to go. Let's uncomment these message boxes. Let's go to the creation kit, at the source, save, it compiled, and I will see everybody in the in-game testing portion in a moment. And we're going to the live testing section. We're going to have 3 different tests: the Factorial, Fibonacci, and we're going to just do a little bit of even odd. So factorial 4 is 24, that's the factorial of 10. Fibonacci at 3 is 2, that's correct. Alright, it's going to do the even test first. 2 is even, that's good. 10 is even. 77 is odd. 3 is odd. And that is the Fibonacci value at 10. It calculated that pretty efficiently in the background, I'm going to imagine. And we just did Fibonacci of 2 since that's a basic case. And it is 1. So everything works, and I will see everybody for the conclusion of this episode. Alright, we are back. So that's the end of recursive functions with return value parameters. If you have any questions over the content of the episode, feel free to message me at on the Nexus. I will have this information in the description as well as supplementary links, although there's not really too much with this episode. That's different from what I've been putting in the description. Also, YouTube's a perfectly alright place to give feedback. If you have questions over past content, feel free to message me as well, or future content. If you have any special requests or just plain scripting help, I'm available to answer to the best of my ability, at least. And I will see everybody on the next episode.